We'll just start with this first one. All right, in this chapter we had a lot of things. We had rational expressions, and so this is an example of a rational expression, and for those we learned to reduce, multiply, divide, and add and subtract. So we'll do a problem of each of those. This one is just going to be to reduce. The word simplify means the same thing. And you factor everything and then cross off. So these problems involve a lot of extra work because you have to factor both pieces here and then do the new step. So remember about GCF, if you only have an exponent of 1, GCF is going to be your choice. So you can take out a 2 there, and that leaves x minus 5. Right? Our denominator is a trinomial. For a trinomial, and this is a nice one with a 1 in front, so we can go ahead and do like a backwards FOIL. Right? Do your sign rules. This says do like signs both minus. Split your x's, and you're multiplying to get 35, and then like signs will add to give a 12. 7 and 5 kind of pops in my head, and it might in yours. If not, you make the list. It's not going to be a long list for 35. 7 and 5 will work. It will add to give 12. So we can put that in. And your check would be 2 pieces of the FOIL. Outside minus 5x, inside minus 7x equals minus 12x. So that means you factored right. I'm going to try to just take those pieces back off so they're not in the way. And then you're ready to cross off. So you can take out the x minus 5. The rest of it you have to leave. And you're good. All right, so factor first. So that is a reducing one. So 2 over x minus 7. All right, 2 and 3 are also reducing problems, just factor first. So I'm going to skip those. 4 is a division problem. And this takes a lot of work, this problem. Z squared minus 11z plus 10 over z squared plus 6z minus 16. Those z's are hard for me. And z squared minus 18z plus 80, and z squared minus 64. All right, so we have to factor everything. So that's 4 problems to factor, and then we actually have to do the steps. So because it takes a lot of writing, I am going to factor and flip on the same line. Division is going to change to multiplication, and your second fraction is going to flip over. Right, so I'll factor and flip at the same time. So you have 3 trinomials and a difference of squares here. Right, so the first trinomial, 2 sets of parentheses. Plus at the end says like signs both minus. We'll put the z's. And for 10, but they're adding to give 11, it's going to have to be 10 and 1. And just kind of check. I'm not going to write the check because it'll be in the way. Minus 1 plus minus 10 gives minus 11. So we're good. Then we'll go to the denominator. And we can put the z's. And this time we need different signs. So we need 1 plus and 1 minus. We're multiplying to get 16. So 1 times 16, 2 times 8. 2 times 8 is going to be your choice. You do have to be careful which one goes with which sign. You want a positive 6, so put that sign with the bigger 1. So we'll go 8 here and 2 here. So minus 2 plus 8 gives me plus 6. Right now, I'm changing to multiplication, and this one's going to flip. So this z squared minus 64 is going in the numerator. Hopefully you would recognize that. It's two terms. It's minus exponent of 2. That means it's a difference of squares. So it is z plus 8, z minus 8. You use your square roots with different signs. Okay, this trinomial is going to the bottom, and it'll go 2 sets of parentheses. Ends in plus, so that says like signs, both minus. Put the z's. All right, and we're looking at 80. I'm thinking of 8 times 10, and I think that actually works. Because they have to add to give 18. So it does work. If it did not work, then you would make your list. 1 second, I got one more. All right. So I'm going to erase that so it's not in the way. And now we're ready to match up and cross off. You can go on the diagonals. So you can go this way. Or let's see, if I go with the pen, maybe you'll see that red dot. Down this diagonal, down this diagonal. You can also go straight up and down. You cannot go across to cancel. So I can go on this diagonal, take out the z minus 10. That's good. And I can't do the z minus 1. Right? If I try the other diagonal, I can take out a z plus 8. Right, that's good. And I have one that I can take out vertically. This z minus 8 can go out vertically. And then I just put everything back together. This one I have a z minus 1. This is 1 when everything crosses out. So I have left a z minus 1 over a z minus 2. You have to make sure you stop there. Don't cross off the z's. If there's a sign between, the whole piece has to stay together. So, if you type this in, you need your fraction button, and you want z minus 1 over, whoops, is that a z? Yeah. Over z minus 2. All right, so the work really is in the factoring. All right, we have a multiplication next, and I think we'll go down and do the one after this one because it has a cube. This one has 3 trinomials and a difference of squares, and we just did a difference of squares. So let's go down and do the next one, which pulls in one other kind of factoring. So question 6. This time we have a multiplication, so we don't have to flip. We still have to factor everything. But this time we have a cube in there, which will be different factoring. So we are going to factor everything. So for our trinomial here, 2 sets of parentheses, I'm going to do the x's. Ending in negative tells us to use different signs. All right, and I'm thinking 5 and 2 for the 10. Right, they're going to subtract to give me a 3. That will work. And I want a positive 3, so that sign needs to go with the bigger number. So we need a 5 here. A 2 here, kind of checking your head. Minus 2 plus 5 gives me plus 3. Right, this one is a sum of cubes. That was the pattern, and you get the cube roots, so x and 5. Make sure you can find a cube root on your calculator. I think you have to push the 3 first. 3. Second, and this one has an any root button on the left side. Right? If you have one that actually has a 3 there, then you can go with it, and it saves you a step. 125. Enter, and the cube root is 5. All right, so when you factor the cubes, you use those pieces with the sign of the problem. So we're going to have an x plus 5 Your second set of parentheses is a big one. It has 3 terms in it. For your signs in it, the first sign will be the opposite of the one in that first parenthesis. So this will be minus. Last one is always plus. And then you get all the combinations of multiplying this x times 5. So we do the first one times itself. X times x is x squared. We do the first one times the second one. X times 5 is 5x. And we do the last one times itself. 5 times 5 is 25. Right, and this will not do more when it comes out of a cube. So you're good there. If you notice, this piece up here, I mean, we would think that we're going to factor that, but it actually is exactly the same as this. So it's not going to factor either. We could try. You multiply to get 25, but you have to add to get 5. There is not anything that does that. And so it doesn't factor. Right, and we'll try this denominator. So it is a trinomial, like signs both minus. Split the x's, and we're multiplying to get 10 and adding to get a 12. Maybe 10 times 2. If it doesn't click for you, make your list. 1 times 20, 2 times 10, 3 doesn't work, 4 times 5. Okay. Let's see. And they're like signs, so it doesn't matter which one goes where. We can check. Minus 2x minus 10 gives me minus 12. So we're good. All right, you have factored everything. This one was multiplied, so no flipping. Now you're ready to cancel. So we try our diagonals. On this one, we can do the x minus 2 matches to the x minus 2. On the other diagonal, we can do this big trinomial. Right, and you also have one that is vertical, straight up and down you can do. Nothing over here. Now, everything has divided out of our numerators. You are dividing, so if everything goes away, it goes one time. You need to put that 1, and the x minus 10 is left in the denominator. So we click in our box. You need the fraction button. We need a 1. And an x minus 10. Good. All right, next is another division. I'll skip that. We did a division. Right, and question 8 gets us to a subtraction. For add or subtract, you have to have a common denominator. And this one does have a common denominator. It has a place where you have to be careful, though. Anytime it's subtract, you're going to distribute that minus to the second set of parentheses, or the second numerator. Right. So, since the denominator is the same, we'll go ahead and put it in the answer. And we can combine the numerators. When you get ready to do that, this minus is going to affect both of these pieces. So you're going to have a minus 21x and a minus 4. Excuse me one second. Right. You can write that all on one line if you like. Might make it easier. So we'll do that. So I have x squared plus 21x minus 21x plus 4. Whoops, I just made that error that I told you not to do. That is a minus because this distributed to both. So minus 21x minus 4. You always want to take time to do that. All right, your 21x actually wipes out when you're going to combine. So you have x squared minus 4. I can put it down here. This is going to reduce. All right, and then we have combined all the numerators. So now we have to try to factor to reduce. The numerator gave us a difference of squares. So we have x plus 2, x minus 2. And denominator, there's no factoring to do. You know that because the exponent's 1. And it would only be GCF. Now you can cross off what matches. And the x minus 2 is going to be the answer. You don't have to write a 1 in the denominator. We'll just look and not type. Right, so that one already had the common denominator. The next one will be similar. It is just addition. So it doesn't have this issue with the minus, so we'll skip it. And we can skip that one. You just keep the 5x squared, combine the numerator. That minus does distribute. All right, question 11. This one has different denominators. So we'll do it. So we have 5 over x minus 5 plus 4 over x plus 4. Right? When you pick your common denominator, you factor the denominators if they will, and you have to have every kind of piece you have. This whole thing stays together. The x minus 5 stays together, and the x plus 4 stays together. So those are actually different. You're going to need them both. So an x minus 5 and an x plus 4. All right. So we're going to have to put on the missing part. So I'll bring down what I have. And then I look at the denominator. This one has x minus 5, so it's missing x plus 4. You have to do the same thing to the numerator. Right? I'm going to bring down my next one. And if I'd left enough room, I could have put it right beside. So when you write these, you might put it right beside. All right, this time I have x plus 4. It needs an x minus 5. And you do need parentheses there. Now, before I multiply all that out, remember what happens next. You keep the common denominator. So there is no reason to multiply that mess out. Just take it in the factored form and put it in the denominator. You don't care about the order. It doesn't matter if x minus 5 goes first or last. Now, numerators you have to combine. So we're going to have to distribute these, and this plus goes with the 4, and combine. So I'm going to write it all. So I have 5x plus 20, and here I have 4x minus 20, and we'll combine. So the 20 and the minus 20 go away, and the x terms combine, so we have 9x over x minus 5 times x plus 4. And you're going to leave it there. There's nothing that would cross off now. This is a monomial, and it's not going to match those. They multiplied out. I am pretty sure they would accept it not multiplied out, because that is standard practice. We will do it. I wish this box didn't open on top. All right, so I'm going to put factored form there. It is standard practice to leave factored form. Still need to be down here. And I'll submit it, and it's happy with that. Okay. And that's what I would do. I would not multiply that out. That's too much work. You don't need to do it. Because if you leave it here, it will also help you if you have to reduce, because it's already factored. All right, the next one asks us to find the LCD. So basically you have to factor. And all you care about on this particular problem is the denominators. All right, so we factor each one. It says different signs. And I'm thinking 10 times 4, but that's not going to work. So I have to use something else. So I can make my list. 1 times 40, 2 times 20, 3 doesn't work, 4 times 10, and 5 times 8. There's your winner, 5 and 8. Those will subtract to give a 3. So I want a minus 3. That needs to go with the 8, bigger number. All right, we'll kind of check. Minus 8 plus 5 minus 3. That's good. All right, so this one, different signs. Split the y's, and 16. So 1 times 16, 2 times 8, and that's going to win. 4 times 4. 2 and 8 will subtract to give us a 6, and we want a minus 6. So we're going to need a minus with the 8 and a plus with the 2. We'll check. Minus 8y plus 2y is minus 6y. All right, we had to factor all that to see what kinds of pieces we have. You have to take every kind of piece you have, and you take it from the fraction where it occurs the most. So we're going to need to take a y plus 5, and it only occurs once in either fraction. All right, let's go ahead and do the y plus 2. It only occurs once in either fraction. Now, you see the y minus 8 in each one, but you're only going to take it one time because that's all it occurs in either one fraction. So you don't need both of those. And that is our common denominator. And you definitely want that in factored form. All right. So we'll do one more of these. This one, you just have to factor this denominator, the second denominator, to figure out your common denominator. Fortunately, it's not mean factoring. Right, because we're adding, so we need common denominator. This is a difference of squares. It's an x plus 3 times an x minus 3. And so that will be your common denominator. You need one copy of x plus 3 and one copy of x minus 3. So you're going to have to work on the first fraction. I am going to just put it on right here. All right, it needs the x minus 3. Top and bottom. That way you're really multiplying by 1, which is okay to do. All right, and this one is good because it already has the factored denominator. Right, now your rule is keep the common denominator. So we're going to just write it down there. You don't care about the order. But it says combine the numerators. So we're going to have to distribute on this one, and then we can combine. So we have 7x minus 21, and we have plus here, so note sign changes, plus x plus 45, and that gives us 6x, and 5 minus 1 is 4, so a 24. Make sure that's right. 5 minus 1 is 4, and 4 minus 2 is 2. Okay, so we're good there. That will factor a little bit, but it is 6 times x plus 4. That doesn't match either denominator, so we leave it like it was. Either of these answers should be correct, because you want to go through this thought process to factor and reduce, but that doesn't match, so this answer would have been fine. Whoa, except Mrs. H made an error. Okay, let's see what we did wrong. some math. Okay, 7 plus 1 is 8, Mrs. H. Which would factor, you could take out an 8, and it leaves x plus 3. Now it will reduce if we do the math right, and if we pick the right one to cross off, the x plus 3 should cross off. Sorry, going too fast. And that should be the right answer. It's okay to tell me if I do stuff like that. 7x plus 1x is 8x, not 6x. All right, so we'll move on from there. That was add and subtract. And we'll go to complex fractions. This section also uses the LCD, and you multiply on the top and bottom by it to make all denominators cancel. Odd and 18. So a complex fraction has a fraction in the numerator or denominator. All right, so you're going to pick your LCD. It is going to be x minus 8. And you're going to multiply up here and down here by the LCD. We really multiplied by 1. That's why we can do this method. All right, and so these will cancel and these will cancel. And what you're left with is 7 over 13, and it's done. So I think it's really cool. 15 is going to work the same way because the LCD is x. So you can work it while I write it down. X plus 3 over x and x minus 4 over x. Your LCD is x. That's the only denominator you have. So you do it top and bottom. Make that one cancel. It'll make that one cancel. So we end up with x plus 3 over x minus 4. You are not allowed to cross off anything here because of the signs. Those pieces have to stay together. All right, this one looks a little harder, so let's do it. And I'm doing more of these because these are questions that don't take a long time to do, but they are new for you guys in most cases. So this one is a little more complicated because it has such a big LCD. All right, so your LCD for all your denominators is going to be x plus 1, x minus 1. You have to have the whole thing. And you're going to put that beside every piece. X minus 1, x plus 1. And I'm really just distributing it through. That's why it's going. And x minus 1, x plus 1. And x minus 1, x plus 1. This is a long problem. All right, clean up all that you can. And then we'll multiply out what's left. So we have 5 times x plus 1 will be 5x plus 5. Right here, watch out, you got that minus 2 to distribute. Distributes to the x minus 1. So it'll be a negative 2x, and it will be a plus 2. Right, down here, x times x is x squared plus x. And this one will be, it's a plus 1, so plus x minus 1. All right, so numerator, 5 minus 2 is 3x plus 7. no factoring we can do there. And this one is giving us x squared plus 2x minus 1. This is not going to factor to reduce. This says use different signs. You're multiplying to get 1. Has to be 1 and 1. Even if it did factor, it's not going to give you a number in the front like this numerator. So that should be our answer. Hopefully, Mrs. H did not make an error here. 3x plus 7, that's the numerator. And that is your denominator. All right, we'll do one more of those. I know, it's overkill on those, but... So here your LCD is going to be an x and an x plus 1. Have to multiply by that whole thing. And I'm just going to do it in the problem here. All right, and then we'll clean up. So this denominator is gone. This one is gone. This one is gone. So we have left here a 9 to distribute. So we have 9x plus 9. Over here, be a little careful. You have a negative with your 5. So it's a minus 5x. And this one we have 1 times x is x. So we have 9 minus 5 is 4x plus 9 over x. You can't cross these off with the sign there. So we should get 4x plus 9 over x. Good. All right, so we'll leave complex fractions. Next question is about domain. And domain, for us, you start with all real numbers, and you have two places where there are exclusions. Denominators is what we're going to have to deal with. You cannot let a denominator equal 0. So this is our problem, and it says find the domain. So numerator is already factored. Denominator is the one we care about. So it's going to factor with different signs. And how about 7 times 3? And so we want a plus 7 and a minus 3. Right, and even though this one would cancel, we still can't let this piece be equal to 0. So we check the denominator. When is this 0? Because we're going to throw it away. We don't want a 0 in the denominator. So x plus 7 equals 0. It would be negative 7. So x cannot be negative 7. This one, x minus 3 equals 0. So we'll add the 3. So x cannot be 3. So, and they put it in solution set notation for you. The set of all x such that x is not equal to negative 7 and 3. You can write it more compact that way. They wrote out the whole thing. And so it is going to be the last choice there. Okay. Yeah, they're trying to trick you if you divide this out, but you still have to make sure you can't let that piece be 0 either. So, solve them both. All right. This one is the same kind of question. We can go ahead and do it just because it's a different kind of factoring here. It is not a nice kind. You have to know when is that denominator 0. That is what you have to watch for. And they didn't give us any kind of hints there to help us. Right, so you have to know when is denominator equal to 0. So that means to factor this. Set it equal to 0 and factor it. And this is the kind with the number in the front, so it's not such a nice kind. I showed you guys 2 ways to do it. One is trial and error, and the other way I showed you was a grouping method. So we'll go that route. The grouping method keeps the first term. It keeps the last term, right? And it multiplies the first times the last, 3 times 50. So we're looking at 150. We want numbers that multiply to give 150. So we can do 1 times 150, 2 times 75, 3 times, so we'll get us a calculator out here. 150 divided by 3 is 50. Right, we can try 150 divided by 4. Okay, we can't use that one because we're getting a decimal. 150 divided by 5 is going to work. All right, so 5 times 30, and actually this, let's see, it's not the choice we want because they're going to be like signs. If they were different signs, we would want that choice because they would subtract to give 25. All right, so we have to keep going. So we'll try 6, 150 divided by 6. All right, and that gives us 6 times 25. Well, those don't add to give 25, so we have to keep going. We can try 7, 150 divided by 7. Doesn't work. 150 divided by 8. Doesn't work because we get a remainder there. So 150 divided by 9. Doesn't work. And 10 does work. 150 divided by 10. All right, 10 times 15. And that, I believe, is going to be the right choice because they add to give 25. All right, so we're good there. We're going to split the middle and use this 10 and 15. I'm going to just switch their order and put the 15 over here with the 3. Each one of those gets an X. And I switched it because 15 has something in common with 3. All right, now you do it by grouping. So we group here and we group here. And so here we can take out a 3x. And then what's left is x plus 5. In this one we can take out a 10. And that leaves us x plus 5. So we did get the common binomial, x plus 5. To get back to the line above, we're missing 3x plus 10. All right, all that work was to factor this so we could see when is this denominator 0. Because we don't want it to be 0. So you're going to set each piece equal to 0 and solve, and then you'll throw those values away. Right, this one, if we subtract a 5, we don't want x to be negative 5. This one is a 2-step, so subtract your 10. And you will divide by 3. So we don't want to get that. So the values we're going to throw away are negative 5 and negative 10/3. Good. So the factoring was the big work there. All right, next we have some solve problems. And for the solve ones, you are going to find the LCD and multiply through and cancel all the denominators. And so first job is factor so you can see the denominators. So this will be a 2 times x minus 2. All right, so for our common denominator, we're going to need a 2 and an x minus 2. You only need the x minus 2 once because they come from separate fractions. All right, so that's what we're going to multiply by. We also have to state what values to throw away. The only section that's going to give an issue is this x minus 2. So if we set that equal to 0, a 2 itself is bad. That would make a 0. And here a 2 itself. So x cannot be 2. When we finish, if we get 2 for an answer, we have to throw it away. All right, so we are going to multiply all the way across by x minus 2. This is really like your equations with fractions, clearing the fraction. Right, so I'm going to multiply by x minus 2. Sorry, 2 times x minus 2. You have to use the whole denominator. All right, let me scoot this. 2 times x minus 2. And this one 2 times x minus 2. And 2 times x minus 2. Now, all your denominators should cancel, right? So this one, my 2 goes out, my x minus 2 goes out. So for this first piece, I'm left with x. Now, the second piece didn't have any denominators, so you're going to have to take this negative 5 times these. So this gives us negative 10 times x minus 2. Right, so it'll be a minus 10x and a plus 20. Right, this one, the x minus 2 will cancel. We will still have 2 times 1 is 2. Right, and that cleaned up to give us an equation. We did get a linear equation, so we can solve, put the x terms together, gives us a minus 9x. Then we should subtract the 20. It's a linear equation, so we just isolate the variable. And we get a negative 9x equals negative 18. And you are going to have to divide by negative 9. And we get x equals positive 2. Now we have to look back, and we threw 2 away. So, there's not anything else to check. The answer is there is no solution, because our answer would have given a 0 in the denominator. All right, does the equation have a solution? And my answer here is no, and so this would just be D and E. All right, so that is an equation, and we hit all the highlights there. Find the common denominator, multiply every term by it. All denominators should cancel. Then you solve. Look back and see if what you solved for throws away. If it does, then there's no solution. All right, so I've got about 30 minutes left. I'm going to stop with those, and I can come back to more if it's needed. We'll do some of the word problems, but we have more content to get through. All right, this one is a different technique for the same thing. You could multiply by the LCD. Right? Or you could solve it as a proportion. Proportions only work when you have one fraction on each side of the equal sign. But if you do, you can multiply across. These are called cross products, across the equals on the diagonal. So we get 12x equals 42 times 14 588, and then divide by 12. And we'll just check that. It actually works. X equals 49. Okay, but that only works with only one fraction on each side. So it doesn't work all the time. Right, so you can use these proportions for word problems though. So let's look at some of those. And basically your rate on each side of the equals is going to be the same. So they're giving us one here. Nevaeh rides 5 hours on a bicycle. All right. And this one actually you're not going to solve that way. It's just asking her rate if she rides 55 miles. And they're going to want it in miles per hour. So she's riding 5 hours. This one, it doesn't work like the normal setup. What is her rate if she rides 55 miles? Because normally they want miles per hour. So they want you to do 55 divided by 5 to give the rate. This will give you miles up here, an hour down here, and divide by 55 and you get 11 miles per hour for the rate. So that one didn't really fit with our proportions. Okay. And this one is not going to either. Hopefully one of those is not on the test. They're not hard to figure out, but use this information to calculate your hourly pay rate. You're paid $135 and you work 12 hours. Divide it to get how much per hour. This is money for 12 hours. So Mrs. H would dump those out of this section. 135 divided by 12. So your rate is $11.25. You could write it like this per hour. You could write the word per. Let's see what they did. All right, they wrote per hour right here. All right, $11.25. All right, let's see. This one is one that sets up with a proportion. They're just asking you to pick the correct proportion. All right, and I would write the words. When I write the first one, I would write the words on it. So a property tax, the tax on a property assessed at, so $920,000. This is assessed, and I'm just writing that. Better not abbreviate that, huh? All right, and this is the tax, $13,800. All right, over here, you have to write the same things in the same places. I'll just leave it A, okay? All right, so if we read the rest, which of the following proportions could you use to find the tax on a property that is assessed at $340,000? So you would put the $340,000 up here because this unit needs to be the same. And the tax is what you're solving for. So, and none of those choices are the same. That's how I would do it if I was going to solve it. So these give you a cross product, and I'm going to show you that if you flip both of these over, it will give you the same equation. So we won't really solve it. But so we have 920,000 x equals 13,000 times 800. I'm not even going to times 340,000. All right, that's the equation from that order. If I had switched the order and I had this one, right, which is in the choice, it's just the number one choice there, it will give you the same equation, so it is equivalent. Whoops, times 4,000. All right, so it is equivalent. So it is going to be choice number 1. And we'll just submit that, and they don't like what I picked. I'd have to argue with them over that. So which one do they say? They're wrong. Okay. We'll let that one go. I'm going to mark that problem down to make sure that we take it out. All right, 29. You probably will not get a question like that because I would rather you solve one. If it gives the same equation, it should work. All right. We'll try to get a problem here that works. Okay. All right. We'll try 30. Suppose you work for a large coffee distributor that has a secret coffee blend it sells to the local stores. You mix the Costa Rican blend with the Guatemala Antigua blend, but always in the same proportion. Yesterday, you mixed 60 pounds of Costa Rican with 18 pounds of the Guatemala, right? Over here, you want to put the same things in the same positions, all right? Today, there is 40 pounds of Costa Rican. Costa Rican is up here. And how many pounds of Guatemala do you mix with it to get your secret blend? So that is your variable. You're going to multiply across on the diagonal. So you have 60 times x, 60x equals 18 times 40 equals 720, and divide by 60. So x equals 720 divided by 60, x equals 12. Good. That is what those proportions are for. And you do need the same things in the same positions. Okay. All right, we can do one more. since we had trouble. All right. So this is a med change in this one. All right. So we have 5 milliliters of Tylenol contains 160 milligrams of acetaminophen, right? Your pediatrician says that your child can take 64 grams of acetaminophen, right? So that should be down here. And this was acetaminophen, right? And so you want to know how many milliliters should the child take. All right. And so you multiply across, you have 160x equals 5 times 64. $320 and divide by 160 is 2. All right. Record the proportion. So it may not match. All right. X over 64. All right. It's just backwards. It should be fine. X over 64. 5 over 160. They flipped across the equals. This is a different setup, but it should still give you the same equation. 160x equals 320. And the answer is 2. So we're good there. All right, formula problems. I am going to do number 33. This one has it in the denominator. When it doesn't have, I was thinking it would have the variable in the 2 places, but it doesn't. All right, so y equals 9 over 10 minus x. And we are supposed to solve for x. Right, so first thing is you're going to have to get it out of the denominator. You're going to multiply on both sides by 10 minus x. All right, and that gives us 10 minus x times y equals 9. We are solving for x. Since it's inside the parentheses, we have to distribute. So we have 10y minus xy equals 9. And now we want to get x by itself. So I'm going to subtract the 10y. So I get negative xy equals 9 minus 10y. And I'm going to divide by negative y because this is multiplied. So that isolates my x. This answer should be fine, and we're going to type this one in to see if they're okay with that. Sometimes they don't like that negative in the denominator, and they'll distribute it somewhere else. So we will type it in. Enter your answer as an equation. All right, so I should have x equals fraction 9 minus 10y over negative y. Okay, so they were okay leaving the negative in the denominator. So it's the same as equation solving steps. Just go for the one that they said to isolate. All right, let's see where we are. That is an equation. That one should have been up earlier in the set. So this moves into graphing, and this formula you need to make sure that you know. And since you can have notes on this one, you could write it down. It is for slope, and slope is your change in y's over your change in x's, and I would label every point. So 2, 8, and 1, negative 3. So this is going to be x1, y1. Every point gets an x and a y. x2, y2. If you labeled them different, it's okay. Just you have to go in the right order. So y2 is negative 3 minus y1 over x2, 1 minus x1 gives me a negative 11 over negative 1, which will clean up and give me 1. All right, so that is slope given 2 points. Next question is the same kind. This one is the same kind, but it's going to give you a special answer. When either the x's or the y's are equal, it gives you a special answer. So the 4's are the y coordinates. That's on the numerator. It's going to give you a 0 on the numerator. A 0 on the numerator is a horizontal line. And the slope is 0. All right, so this one, the slope is 0. If it ends up as 0 in the denominator, it is undefined, and it's a vertical line. All right, so 38 is a good question. This asks us to write the equation of the line. Your formula that you need to begin with is the point slope form. Y minus y1 equals m times x minus x1. And they are giving us m equals negative 6, and we are passing through this point. All right, so we're going to plug in. You plug into the ones with the subscripts. So we're going to keep this general. All right, so this is x1, y1. So we have minus a negative 17, which will turn into plus. And this is x minus 3. All right, so this will make plus. So y plus 17 equals, and we can go ahead and distribute because they ask for slope-intercept form. So we need this cleaned up. Minus 6x plus 18. Now, for slope-intercept form, we have to isolate the y. So get y by itself. So all we have to do is get rid of this 17, and y will be by itself. So if y equals negative 6x plus 1. All right, and they split it up for us. Negative 6, they gave us the x, plus 1. All right, so that's a nice general one of those. For parallel and perpendicular, what you have to know is lines with parallel slopes are the same. Perpendicular lines have slopes that are negative reciprocals. And that may be spelled wrong. All right, we'll go ahead and do 40. Okay, so we have to find the equation of the line that is perpendicular. That symbol means perpendicular. It intersects at a 90-degree angle to this line. And to find your equation of the line, you need 1 point and you need a slope. So first thing we're going to need is the slope, and our line is perpendicular to this line. So that tells us that our slope is going to be the opposite side and flip it over. So it will be a positive 3 over 1, which will be 3. right? Then we have a point, 9, -8. We go back to the point slope form, y minus y1 equals m times x minus x1. So y minus a -8 equals 3 times x minus x1. We have to clean up again, so we have y plus 8 equals 3x minus 27. And we'll see if it gives me more room that time. So I'm going to subtract an 8. So that gives me y equals 3x. These are like signs, so they're going to add 3x minus 35. So that was a good workout on that one. Okay. And we'll leave the rest of these. This one, to get to standard notation, you have to get those fractions out of there, right? And standard notation gets x and y on the same side. All right, so that was another question with, oh, this is about systems. We did systems last time. If you have a graph, it's the point where they cross. That is one solution. If they are parallel, there is no solutions. If it's the same line, you get an infinite number of solutions. So this one has a solution at -2, 4. That is where they cross. All right, we can fit in another problem, maybe 2. All right, this one is 48. All right, and our system, you basically had 3 ways to solve a system. Only do graphing if they say you have to. The other 2 methods are substitution and elimination. Substitution is good if you have a variable isolated, which we do have in this case. We have a y isolated, so we'll use substitution. Right? And so in the second equation, instead of y, we're going to put 2x minus 1. You need parentheses. And then we put our 8. So we have replaced this y. Right? That gives us one equation in one unknown, which we can solve. All right, so we have 6x minus 4 equals 8. Add your 4, 6x equals 12, and divide by 6. So we get x equals 2. Now you have to substitute the 2 back into x. So we'll do y equals 2 times 2 minus 1. So 4 minus 1, this one gives us 3. Your answer as an ordered pair is 2, 3. All right, I'm not going to draw it. They're going to cross at that point. All right, let's see if I can do one by elimination. All right, that's going to be a hard elimination, but we'll squish it in, okay? 52. Let me see if that's a special one. Nope, it's going to give me an answer. All right, so basically with this kind, you want your variables lined up, and you're going to multiply by something so that when you add them together, they're going to cancel. In this case, we're going to have to multiply both of them by something. Sometimes you only have to multiply by one of them by something. All right, so we can either pick the x's or the y's. I'm going to just pick the y's, and if I can get this to 15y, they'll cancel. So I'm going to multiply the top one by a 3, And that'll give me 15y, but I need this to be a negative 15y. So I'm going to do this one by negative 5. So I'm going to rewrite those. So I have negative 15x plus 15y equals 15. And down here I have 20x minus 15y equals negative 35. Now I'm going to add the equations together. This one will cancel, and so we have 5x equals, different signs subtract, and x will equal 4. Then you substitute it back into either equation. So I'll do the bottom one since I've rolled it up. So negative 4 times 4 plus 3y equals 7. This is a negative 16. So I'm going to add 16 to both sides. So 3y is equal to 23. All right, and so I have to divide by 3. So y is going to equal 23 over 3 if I did not make an error. So this is 4 and 23 over 3. And let's see if that was the answer. That is not the answer, so Mrs. H has an error. And we are almost out of time. Let's see if I can spot it pretty fast. Right, make sure I did not copy wrong. All right, so I multiplied this one by 3, negative 15x, positive 15y, positive 15. That one's good. This one I did times negative 5. 20x minus 15y minus 35. Okay, the error was not there. Right, now I add them together. 20 minus 15 is 5x, and this should have been negative. Because the larger one should have been 20. X equals negative 4. Right, so let's fix this. We can fix this pretty easy. This was just plug in. And I plugged into this equation. Sorry. All right, I should have plugged in a negative 4 here. So I had negative 4x, so negative 4 times negative 4. Sign error from up there. See, that caused all kinds of trouble. This gives you 16 plus 3y equals 7. So I add 16. And that's still going to give me 23. No, I should not add 16. I should subtract 16. It is positive. Wow. See what happens when you try to hurry. Can't even solve a linear equation. 3y, 16 minus 7 is 9, and divide by 3. So y equals negative 3. So negative 4, negative 3. Sorry about that. 2 sign errors there. Okay, we better end on that. You have to scan your work. So write, this is for Jake's question, right? And that is important for your test. You write your work on paper, numbering your problems, and then you're going to scan it. If you haven't done that before, put an app on your phone. There's a free app called Genius Scan. Easy to use. So you put it on your phone, you hold your phone over your paper, push the little button, it's usually an orange rectangle, and it will scan it. And don't click, let the phone click, and then you move to your next page, and it will click, tell it done, and upload it to your email it to yourself, and then you'll have a document. Save it on your desktop and upload it. Through the left toolbar, there should be something that says PDF test uploads, and you will load it there. So Genius Scan, free app for your phone. I accidentally exited the work. What module is this again? This module is the review for your test. So test 4, practice problems. It is in, let's see. Oh, it's not going to show on mine because I went through. So you go through My Open Math, and it is module 9 under test 4, and then it will be the test 4 practice problems. So module 9, test 4 practice. Any other questions? You're very welcome. All right, we will stop there. If there's nothing else, I'm sorry for the errors today. All right, you guys have an awesome day. Thanks for coming. Good luck on your test. I look forward to seeing them. You too. Thanks.